Welcome, everyone. We're just almost at 12:30, so we have a couple little things to housekeeping, and then I'll turn this over. I'm Melissa Hanson, the Research Program Director for the Washington State Wine Commission. We do these WAVEx webinars, every month or so. They have replaced our full day long WAVE meeting, which is Washington Advancements in Viticulture and Enology. Hopefully next year we can start that up again. But for the meantime, we're on the Zoom mode. Just to remind everyone, put questions in the Q&A, and I will be sending a recording link to everybody who registered, and it will also be posted on the Wine Commission website. So look forward to that in a day or so. And a plug for the next WAVEx, which is, the next WAVEx, which is May 27th. And that will be the future of powdery mildew control. Dr. Michelle Moyer, Dr. David Godowry from Cornell. Michelle is with WSU. We'll be looking at the UVC light device and also powdery mildew resistance. And then my last is this. I just want to put a plug for these WAVE and WAVEx webinars are sponsored by the Wine Commission and Washington State University. It's a great team effort for us to make sure that we're sharing the latest research, not always waiting for it to be completely done, but trying to get it out into the user's hands. So I'm going to stop sharing, and Dr. Karkee, if you share, and while he's doing that, Dr. Manoj Karkee is the Associate Professor in Biological Systems Engineering at WSU, Washington State University. He received his PhD in Ag Engineering and Human Computer Interaction from Iowa State. His research program looks at sensing, machine vision, ag robotics, and he works at Prosser at the WSU's Irrigated Agriculture Research and Extension Center. We call it IREC. And in 2020, he was awarded the Railbird Engineering Concept of the Year by the American Society of Ag and Biological Engineers. And in 2019, he was recognized as a pioneer in artificial intelligence and the Internet of Things by Connected World Magazine. So this is a research project that Dr. Karkee is undertaken on behalf of the Washington wine industry. And it's not completely finished, but we wanted him to update growers with where we're at right now. So with that, I will stop. And Dr. Karkee, it's yours.
Thank you very much, Melissa, for that wonderful introduction. And thank you, everybody, for being here. As Melissa mentioned, I'll be sharing some of the accomplishments we have achieved so far in a project funded by the Wine Commission. And we'll be also presenting a few ideas that we are considering for the next phase of the project that has also been approved for funding, looks like recently. So thank you, Melissa, and the wine grapes and wine research program for supporting these projects. So with that, let me move a few things around here so that I can see the slides better, and then we'll begin. So Melissa, as we discussed, this should be around 40-45 minutes of presentation, right?
Yes, and then we want to allow about 10 minutes or so for questions.
Sure. Okay, so again, my name is Manoj Karkee. I work out of the Center for Precision and Automated Agricultural Systems, which is a part of the IREC campus, the Irrigated Agriculture Research and Extension Center here in Prosser. This project has been conducted in collaboration with a number of researchers and industry partners, as I have listed here. Dr. Naidu Rayapati, Dr. Marcus Keller, Dr. Russell Smithman, and Dr. Yin Zhang and Richard Huff from industry, to name a few. I'm looking at a few aspects of how mobile or cell phone-based technologies might be helpful in vineyard management, and we'll be focusing particularly on counting and sizing berries and clusters, and potentially leading that to yield estimation in vineyards. First, just quickly, why this is important. In wine, mobile vision system is going to be, has already been to some extent, but is going to be more and more practically applicable tool, in my opinion, because the cell phone and smartphone, some other mobile devices are really ubiquitous. We have them with us all the time. They have a lot of sensors, really powerful sensors, and even computational capabilities in them that could be utilized to do a lot of things that might be helpful in farming. In this case, it's vineyard management. Some of the sensors that are really useful include cameras, 3D sensors that some of the devices have included in recent years, global positioning systems or GPS sensors, and inertial sensors that can tell us the orientation of these devices. And because we have those sensors and a very good computational capability with these mobile devices, a machine vision system can be adopted rather easily. Certainly not as easily as in a big server computers, but these cell phones and other mobile devices have capabilities to perform a lot of image processing techniques in themselves. But also we could use cloud computing mechanism and connect to these devices so that these devices can only focus on the front end kind of activities or efforts, such as taking images, resizing them, doing some pre-processing if necessary, and then uploading those images to the server. And that's where the most powerful computational infrastructure would be sitting for us to analyze these images the way we would like. So this would provide, in general, a simple click and go kind of solution for various things that we'd like to do in farming. So one example, as I mentioned earlier, that we are focusing quite heavily on is crop or yield estimation in vineyards. Just a quick background, maybe the audience knows these things better than me. I'm an engineer. I know horticulture just a little to kind of help me kind of formulate the research projects I work on. But we collaborate with experts in horticulture, both from the research as well as the industry side, so that whenever we need any kinds of in-depth knowledge and experience and expertise and understanding around how these crops are grown and a lot of physiological aspects of these crops, and then again we get those expertise from our collaborators. Now, briefly, however, just to set the stage for us, crop or yield estimation in vineyards are mostly performed manually these days, and that includes estimating various factors such as plant density, number of producing plants per acre or per unit area, average number of clusters per vine. Some literature suggests that hundreds of samples are taken from a given field of several acres, and these samples are these sample vines are counted manually to find how many clusters are there, and which is then used to estimate average number of clusters in these vines. And also average cluster weight, which is a more time-consuming operation. It is a destructive process. Number of samples are collected from sample vines to remove them from these vines, to take them to the lab and weigh them and estimate average weight of these clusters. This process can happen throughout the growing season, and this is really labor intensive and often also leads to inaccurate estimation. particularly because we may be limited by the amount of labor being used in these processes, and we might limit our sample size. And also sometimes we may not be sampling as frequently in an area that is really varying, and that might lead to inaccuracies. These kinds of limitations would impact the overall management of harvest and post-harvest operations in vineyards. And then that's why I believe tools like the one that I'm discussing today would be really valuable. There has been research and development efforts around automating or developing automated tools for helping crop estimation or yield estimation in vineyards. This is one of the research priorities for various organizations, such as the Grape and Wine Commission program here. Um, some of the efforts around the world include those from Carnegie Mellon University. There is another one from Australia. There are a couple of private companies. I think one of those is Bloomfield Robotics. These companies and university or academic researchers are focusing heavily on developing sensors, sensing systems, lighting systems, and then a platform that could be used to install the sensors and drive them around in vineyards. These tools are good. They can provide pretty good information, pretty good results in terms of counting clusters and berries and then projecting that into total yield in a given plot. However, they are generally more complex. They generally require experts or at least some skilled labor to operate them, and they can be quite costly. Both the imaging system, the platform that needs to be installed on, and the operation itself might be both complex and costly. And they are also not as portable as the handheld devices that I'm talking about today, or at least handheld devices based solutions would be more widely available to almost everybody who is involved in these kinds of farming operations, and that's why I think it's more portable. Also, these for some of these reasons, the efforts that have been there in developing these relatively more complex and complicated machines have not been commercially successful so far. It doesn't mean that they may not be out there in the future, but at least at this time, based on my understanding, they have not been very successful in being commercially adopted. So to address these challenges, um, I started to look at a cell phone-based solution a couple of years ago, and started working in this area. I've given this name Count for an application that is being developed for counting berries, counting number of clusters, counting berries inside those clusters, and then extend that to crop and yield estimation in a vineyard. It is a kind of a conceptual picture in terms of how it works. There is this vine there with a lot of clusters. So we could take images with these mobile devices, and there will be a near real time results provided by the application in terms of how many clusters that we're looking at and how many berries are there within a given cluster. In the first phase of this project that was funded by the Grape and Wine Commission, Grape and Wine Research Program, include the efforts towards acquiring images of sample vines with a smartphone and display berry and cluster counts in near real time, as I mentioned in the previous slide. Sample location can be determined by the application based on the prior knowledge of the vineyard, or if it is a new vineyard and we don't have much information about the vineyard in the application, uploaded, users can select the sampling locations and go take these images, and the application would perform the remaining operations. Calibrate the estimated berry and cluster counts with with manual measurements, meaning certain these kinds of imaging systems would only see a part of the overall crop that is there in these vines, because some of the clusters are blocked by others, and leaves might be also occluding some of the clusters. And so we have to perform calibration studies to relate what we see to what is there. And that's another effort going on right now, and have made some progress in that area as well within this phase of the project. Another correlation is from the number of berries that we see, the volume or the size of these clusters that we see or estimate by the cameras, to the weight of these clusters. And so we could also do manual weighing of these clusters, take images with the cell phone, and then correlate what we estimate with the image processing system to what is the actual weight of these clusters. And that's also very much helpful for overall crop estimation. How does it work? In a little bit more details in terms of the overall system architecture, this is how it looks. Client side on our left is the application, the app that we have developed that runs on these devices. It could be a cell phone, it could be an iPad in the future. Right now it runs only in Android devices. It could be any other kinds of tablets, where again we could collect one or stereo pair images. We could also scan a given vine or given section of the vineyard with these cameras that are operated by the application running in these devices. Now, those images, based on the network connectivity and other requirements that are related to what is being done. For example, if it is berry counting, we might need relatively higher resolution images, versus if it is only counting clusters, so we might not need as much of a high resolution image. And that's it. Based on those applications, um, the cell phone itself would perform some pre-processing algorithms that would minimize or reduce the resolution, rotate it if necessary, remove some unnecessary parts and things like that. And those images would then be uploaded into a cloud computational platform. We can also call it server side, the right side in this diagram here, where we could do a lot of image processing operations using some of the latest and really powerful artificial intelligence techniques called deep learning and other machine vision image processing techniques that we can run in these server computational units. Again, those could be sitting in the cloud, and that's the architecture I believe would be more and more powerful and helpful in the future. But as I will be discussing later, in situations when connectivity is not available, or we, in some other ways, we prefer using everything on a cell phone, we are also looking at image processing, machine vision algorithms running right inside the cell phone computational system itself. There are also new techniques called edge computing that allows most of the computational operations happening in the server side, the client side, the cell phone side, and some minimal operations happening in the server side that could also be investigated in the future. So that in the middle, we have what we call middleware that provides a framework for back and forth communication between the client side, which is the application, again, running in these cell phones or mobile devices, and the server side that might be running in the cloud. It could be running right inside the cell phone, again, if that is the preferred architecture. It could also be running in a given organization's server computers, if that is another preferred way. But I think most generic would be the cloud computation. Using this architecture and these techniques that I have discussed so far, what we have done so far in this project is that we've collected thousands of images over the entire growing season. We have 2 full growing season worth of data collected, again, in the past 2 years. We'll be continuing those efforts in this growing season as well. That is coming up rather quickly here, as you can see. And then we have developed machine vision algorithms that would be used, or the models that would be used to detect clusters, count them, and then also detect berries and count them within those clusters. They're being developed and tested. Mobile application that is, again, runs in these cell phones or mobile devices have also been developed already. That is a version there. In fact, we have developed a couple of versions, at least have gone through a number of updates and upgrades over the last year or so to perform some of these operations more efficiently. And we have already integrated cluster detection model with this application. So this application now runs and performs the cluster detection operation for us. Berry detection model has also been developed, but that's still running in a laptop computer. One of my students is working really closely on that model, and she is almost ready to bring that also into the overall application-based environment. And now we're also looking at correlation model, as I discussed earlier, to estimate the weight of these clusters based on the number of berries that we've counted within those clusters. And again, that will also be added to the application over the next few months. A few sample images showing how this application works. We have this, as seen in this image, we have this environment where we can create a new field. For example, a new field here, test Prosser, Washington Grape Vineyard, is kind of a sample vineyard that we have created. And then we can add as many fields as we like. And give me 1 second here. It looks like there is some background noise here. Sorry about that. So this application, again, allows us to create a field, and that field could be viewed in a map like this, as we can see here. Or we could also bring up a satellite image so that we could see where the field is more accurately, or at least have a better feel of where it is. We could also draw or delineate a boundary for the field that we are looking at or working on. And then once we define the field and locate it and add a boundary for the field, we could start taking images using the cell phone cameras themselves. Again, this application allows us to take the photos and then upload those photos to the cloud computational platform that would then performs the image processing operations and send us the results back. That could include the number of objects that were counted, in this case, number of clusters that were counted in these images collected by the application using the cell phone cameras. Also, in the next picture or so, we can see here the boundaries, kind of a tentative locations of those clusters that were detected by the the system. In addition to count, we would have those delineations of the clusters. We could also do kind of a polygon drawing instead of circle drawing in this kind of situation, but I think for us to just get a sense of where these clusters are, circling them was the easiest and most convenient way, at least in my opinion. But again, if we want to see the more accurate boundary of these clusters, we could go around those clusters and draw the polygons based on the results that the cloud system has provided. Here is another example of the image and how the clusters were detected. Now, I would also like to add that we can also use already collected images that might be sitting in the cell phones or mobile devices using this aid from library button here. Instead of taking photos in real time, we could upload previously collected images and perform the same operations on those images same way it would be performed for the images collected right now with the application using those cell phone cameras. Again, we could choose either the real-time imaging, or we could use the images collected in the past and process them in batch whenever necessary. So that's where we stand right now. Where we are going next include developing a spatial sampling and correlation model for block level yield estimation. Again, right now we're in a way helping users or workers working in the field to collect these samples more efficiently, more accurately, rather than doing a lot of manual counting and manual weighing. I think this tool, as it stands now, can provide an automated tool for being more efficient and fast in counting and estimating weight of these clusters. The next phase would be then extend that to take as now take a large number of samples as necessary from different field locations, and use that information to convert into the projected yield for that field. In addition to that, we're also looking at adding other capabilities to this application. So one of those is what we call lag phase detection. So because we are taking images over a growing season, our collaborator, one of our collaborators brought this idea of how and what if we could detect, or at least investigate the ways potentially we could detect lag phase in these vineyards. And as I further looked into the physiology of how these berries grow and understood more about what the lag phase is, I started to realize that this could be something really useful tool to be added to this application, so that in addition to counting berries and clusters and other things that might be possible, growers and users could also go back to the same clusters every week just before these lag phase windows, and then because we can track the berry size quite accurately, at least from the preliminary studies we have done, I think we'll be able to detect lag phase with this tool. And if that happens, I think it will be really useful for the users. Another capability that we're trying to aid is the viral and non-viral symptom detection using, again, similar deep learning based image classification technique. We have collaborated with Dr. Naidu Rayapati in this case because he's the virologist with a lot of knowledge there. Again, we'll not be doing a lot of field work ourselves. We'll be collaborating with the virologists and other people who know the disease. Our goal here is to get images of these target or capture images of these target symptoms with the help of our collaborators and use the same image processing, image classification techniques that we have developed for counting berries to perform uh, distinction between viral and non-viral symptoms. We're also, as I mentioned earlier, looking at additional capabilities for device-based and edge computing techniques so that it kind of widens the practical applicability for users with different infrastructures and different needs. Um, there could be other aspects of field operations, field management that might also benefit from this kind of berry detection, berry counting, cluster detection, cluster counting, and yield estimation tools that we are working on. For example, I think it could be useful to detect if there are reduced number of clusters or if the berries are not growing as they should, and things like that could be detected more accurately with this kind of application, and that can provide some let's say timely information in terms of detecting issues and potentially managing those issues in these field operations. Next, again, I would like to thank Washington Grape and Wine Research Program for accepting our proposal to move towards this direction and providing funding for 2021. Now, I would like to briefly, okay, before that, let me just quickly show here a couple of images that show kind of a preliminary results in terms of how this application could be used to detect viral and non-viral symptoms, as you can see in these leaves here. I've already discussed about that. But in the next couple of minutes, I would like to share some experiences I have with the Apple crop root estimation using the similar app that I have developed in the past. And we're trying to bring that experience to Vineyard and to complete the project that we're currently working on. About 3 years ago, I started developing this kind of similar application for counting apples in orchards. And it is just the same architecture, same principle, almost same kinds of mechanisms, but only the difference would be the models that we have developed. In this case, the deep learning model, the machine vision model that we have developed would do apple counting. And in our vineyard application, the model would be different and would be trained differently to detect clusters and berries. So in this application that we developed about 3 years ago and tested a couple of times in the field, that includes grower or user side application like what we discussed earlier. It include access to cameras and photo gallery. It would have tree sampling data, number of tree number, row number, like the location of the tree. And it would also have orchard information such as number of rows, number of trees in each row, row spacing, inter-tree spacing, and things like that. In the server side, this application has a database management system that would allow us to store all the images uploaded by the users. And it has a machine vision algorithm using deep learning, as I mentioned earlier, that would detect and locate these apples. And then it has a little tool that would collect those results and send those results back to the application. And right now, this is also due to some funding and the practical challenges, we have not fully developed this application to the extent we would like. We are continuing to add capabilities to expand this to large scale yield estimation for orchards as well. And that's where kind of both applications stand at this time, um, kind of similar direction for the future in terms of bringing where we are to field scale crop load estimation or yield estimation. In terms of information processing at the server side, I already mentioned about some of these, but a little bit more specifically, a little bit more technical details here. The machine vision algorithm uses a technique called faster RCNN, which is a kind of a artificial neural network model, deep learning model in less technical term, that would be trained using hundreds of manually classified images, meaning these hundreds, sometimes even thousands of images would be manually process to locate where the apples are and where the leaves are, where is the background, where is the sky. All those classes of objects or pixels in these images would be manually delineated, and those images would be used as examples to train these models. And in our vineyard application, these images would then include labels for where the clusters are, labels for where the leaves are, where the trunks are, labels for where the berries are within those clusters, and those images would be then used for training the model that we have developed, sometimes something like faster RCNN that we have mentioned here. In terms of apples, we have considered 2 or 3 different varieties. In terms of vineyard applications, we have performed that, I think, with 2 varieties so far. And in fruit counting and sizing, as I mentioned earlier, requires a correlation between what we see and what might be there. A little bit more technically, we can represent the relationship between the number of fruit counted by the application and the number of fruit that are actually there, that were counted manually using a function, as you can see here. Basically, what all it tells is that we are correlating what we see, what the camera sees, to what is actually there that were counted manually. And same thing happens with the diameter, the size of the fruit. And we have also extended it to a full scale yield estimation for one small block of Fuji apple orchard. We tested that for 2 years, and we found very good results, as we can see in these following slides. So here is a correlation between count, the number of fruit that the application has counted, in relation to actual number of fruit that are there. And we can see certainly this is not a perfect correlation between what we've estimated with the app and what is there. But for these kinds of really variable, biologically driven systems like what we're talking about, orchards and vineyards, what we have found is, in my opinion, a very good and quite reliable relationship between these two. And that gives a kind of a confidence that this kind of mobile application-based tools would be practically applicable for counting number of fruit, a number of clusters, and other objects of interest in these agricultural fields using cell phone-based technologies. In terms of fruit size distribution, as you can see, the shape of these two histograms are very similar. that tells me that whatever we have counted with or whatever we have estimated in terms of fruit size with our application is not much different than what was actually there that we estimated or actually calculated using manual measurements. Here is an example of what happened in the field. So this particular field was about that we covered was about 10,000 square feet, which is about a quarter of an acre, not a lot. But within that field, with our application, we estimated about 33,000 fruit of these Fuji apples. And the apples counted in the packing house that were provided to us by our collaborator was 32,241, which tells me that it's really close to each other. So again, this is one field, one time, one environment, certainly something not enough to claim that we are 99% accurate in this, but this is really promising, and I believe this could be further validated through other sites and other varieties and even larger experimental fields, which we have not been able to accomplish yet. We did some data collection 2 years ago as well in the same field, but we want to expand this as well to wider field size and varieties. And again, something that we'll be looking at in the future. So we have a quick video here, if my internet allows, that takes maybe 2 to 3 minutes at most, and then we'll be done, and there will be time for questions and answers. So now I'm sure the sharing is still with the slides. Let me share this quick video here. I'm Manoj Karkee from Washington State University, Center for Precision and Automated Agricultural Systems. Today we are here in an orchard evaluating one of our applications for estimating apple crop load, and we're hoping that this will be a very efficient, useful tool for growers in the future to use in this kind of setting to get a sense of how much crop they have this year. We have a quick application that we have developed for this. This is not the best application out there yet. Works in Android right now, but because we are just testing our system right now, this gives us a tool to do that. We have functionalities to open camera, and then what it does is that you can point it to your trees and take pictures like this, and which are then uploaded to a server running somewhere. In this case, right now it is running at our center. There is a big server computer where we can send the pictures and processed to find out apples and their size. And that information is sent back to the application, and we use that to display the results, and circle the apples, and also count how many apples are there. Ideally, what we want to do is that use this system and scan a tree like this up to the top, and then it will automatically give you back how many apples are there in that tree. And then if we take enough samples, that could be 5% or 2% of the trees in an orchard. This should theoretically, ideally give you a very good estimation of your expected crop load. Last year we did this in this particular block for 3 rows, about half an acre or something like that. and our estimation accuracy was more like 95%, a little bit more than that. We did a blind estimation, certainly. Our app and our program estimated the crop load first, and then we got the number from our collaborator after packing the fruit in the packing house. And we exchanged the results. It was very close to each other. So we're really happy and excited. And we're repeating that process again this year, right at the same orchard here that we're seeing, so that we can see multi-year estimation and see how close we are year after year. So not sure if you're able to see that. If I can close this guy.
We do have a couple questions, Dr. Karkee.
Sure. So let me come back to here, and basically I just want to share my last piece of thoughts, and then we'll be ready for the questions and answers.
Great.
So just to summarize, I think these kinds of applications would be, I think I'm not full screen yet, so I think, yeah, good. So to summarize, these kinds of applications, I believe, would be simple and practically applicable for efficient vineyard management. These are available all the times with us. Quick solutions for growers, managers, workers, whoever is involved in these farming activities, expected to substantially decrease farm labor and improve effectiveness, in my opinion. And finally, they're portable and scalable and affordable, because all the hardware is already with us, and the software can be even free or really low cost, depending on how we manage the application in the future once it is available for operation. With that, thank you very much. Here is my email address, just in case if you have more questions after the discussion today, and or in any way would like to communicate with me. Here's my email address, or Melissa may have one as well. Or you can just type my last name, Karke, and all the information will be there in the Google. With that, thank you very much, and would be more than happy to answer whatever questions we might have.
Okay, so thank you, Dr. Karkee. You know, the wine industry is excited because, as he mentioned, very portable. Yes, it does not see through leaves. That's one of the difficulties in all of crop estimation right now, is the occlusion. But we see this as kind of a step, at least, towards fully being able to run something down the row and knowing what your crop is. So this is kind of an in-between step. So here are a couple questions. When you say fruit recognition, are you referring to grapes in general, or are you having to calibrate based on each variety?
A very good question. When we have early stage model that we have been working on, grapes, I think for all varieties, again, I don't have as wide of the knowledge of these grape varieties, but I assume they look very similar and the size would be very similar in this early stage. They're greener and small berries, and our goal is to make it work for that stage around lag phase a little bit earlier than that. And in that situation, I think it will be quite applicable to many different kinds of varieties. How accurately we could do that still needs to be further validated. As it gets closer to the harvest, when we have white varieties and red varieties looking different, I think it needs to be calibrated at least between red and white varieties. And if for red varieties, I believe when it is done for one kind of, or when the model is developed for one kind of grapes, or even more accurately, we could develop a model that includes training data from a few different varieties, putting them together into the development process. Then it would be able to detect the berries for all kinds of varieties for us.
Okay. Is there a standard protocol for taking the photos? Do you need to be 3 feet from the trunk, or do you use portrait versus landscape, a time of day? And would that protocol change for whether you were taking white or black, red grapes?
Very good question again. We are trying to add 3D sensing information with the overall process. And if we are able to add 3D capability, then it would automatically find the distance for us. And that way we can calibrate for the distance automatically so that we don't have to prescribe how far the camera or the phone should be. Right now, um, we are capable of processing images as long as they are within certain range. In this case, I think about 3 to 5 feet from the canopy. But if it is too far, we cannot see the berries or clusters to the size that we expect. If it is too close, a berry might look like an apple for the processor, and it might be confused. So we'll have certain protocol in terms of distance, but that is something we're trying to avoid. In terms of lighting, very good question. We want to avoid a lot of direct and indirect lighting in the same image. So if we can, for example, take the images from the sunlit area with most of the things hit by the direct sunlight, or go to the other side where most of the things are under shadow, it should work one way or the other. But if there is a mix of light and shadow, in some berries bright light and some other berries under relatively dark shadow, that will minimize the accuracy. It will still function, but it will minimize the accuracy. In terms of day and night, with cell phone based imaging, we are trying to make it work only throughout the day, but it doesn't have as good of a flash capability for nighttime operation. A lot of more complex systems like the one I mentioned earlier from private companies and other researchers are using strong flash synchronized with the sensors or the cameras that will work both day and nighttime equally well, I think. But cell phone based imaging might work better in the daytime as far as my experience so far. We have not tested in the nighttime yet.
Okay. And do you think there'd be a difference between the color of the variety, color of the grape?
That is the modeling aspect that we discussed earlier. So as long as this is red, a model that captures different red varieties together, I think it works for all kinds of red varieties equally well. I think the protocol for distance and lighting would not be dependent on the variety.
Okay. And then one more, how do you go about denoting objects in the training set? Are there groups that offer this service?
This is something the modeler does, like I'm doing this right now. As a user, we don't anticipate them to go through that process. As a user, they should be able to use it as a kind of a plug and play, ready to use device without any calibration by themselves, at least in terms of training the model, collecting all the images and delineating it delineating it manually and training the model. There might be other calibrations where the users might have to test it and validate it for their operation. For example, collecting, let's say, a number of clusters, weighing them, and comparing the weight that they have measured with the weight the application has estimated for them. That kind of validation might be necessary, and that kind of tweaking might be necessary for users. But I don't anticipate, as a programmer, users also training the model, and that relies on us.
So, okay, can it get at berry size? Because, you may have in a single block a range between, like 0.75 to 1.1 grams per berry average, or in different vintages, it may average.
Yeah. So our assumption at this time, which might have to be kind of reconsidered if that is not the case, but the assumption at this time is that the volume of these berries at a given time during the growing season would have a very good correlation with the weight. So if the berries are small, we're assuming the weight would be also small. So we'll be developing that correlation model for a given growth stage, for a given crop. This is the relationship between the volume or the berry size to the weight. And we'll be using that model. And if it turns out that for the same variety, same growing stage, they may have different volume to weight ratio, then that calibration needs to take place for each kind of operations.
Um, so the industry needs an estimate early enough to make thinning decisions. If you take images while the berries are green, how do you estimate their final size?
Yeah, so certainly this is where the berry growth model comes into play. I think early on, our goal would be to show how many clusters and berries are there, and however growers would like to use that information is one thing. But then also during the lag phase, looks like there are established knowledge that relates the berry size during the lag phase to the berry size during harvest. Looks like it's generally twice as big or around that. That kind of um, berry growth model could be used to predict what we see early on to what might be there at the end of the season. But again, this is something relies on the existing berry growth model. And if that model is not reliable, I think it's more the decision support tool for growers. So I have these cluster densities and these many berries in a given cluster on average. What do I do about them? But I think the crop yield estimation would then be more like maybe in the if it is reliable for the lag phase estimation, which I tend to believe there are a lot of literature and my collaborators suggesting it is quite reliable. So in that case, I would say if I do it in the lag phase, I would double the size. But any other time, maybe we don't have as reliable information. So that would be just continued over time. And as we get closer to the harvest season, it will be more accurate in terms of the overall yield.
Okay. Um, Perhaps I missed this question during the presentation. What types of grapes did you count and how many years have you done the tests and then compared them to real harvest results in order to ascertain if the modeling is actually working? Also, what is the percentage accuracy of the tests and projections versus real results? And if you haven't accomplished that yet, how long before you expect this can be useful in our vineyards?
I tend to think this is the last part of it. We have not done a lot of comprehensive field calibration. We're still focusing on the modeling side and how accurately we can do in terms of the model being able to tell me how many clusters are there and berries are there. From that point to how many are in the field, and that correlation between what we see to what is there still remains to be done. Um, how long in the future? As I mentioned earlier, we have recently gotten another round of funding for 2 years. I believe at the end of 2 years, we'd have a model that has been calibrated, at least in a couple of places, in a couple of varieties, and something I think that could be applicable for initial or early adopters, at least to see how does it work for them, and actually telling us whether it is working for them or not. I would assume somewhere between now and this next 2 years, I would be able to release early version for users, growers to see how it is and to get a feel and do some testing themselves. And by the end of this 2-year project that we're starting now, my expectation is that there will be a version that is quite stable and provides some good reliable information for growers. It may not have everything that we like, but something that is useful for growers.
Okay, another one. The video that you showed indicated you might be thinking of using a video to scan the estimation, like on a tree or in our case, in a vine. So is that what you're thinking? You would use video to scan or a one-shot picture?
In vineyards, given our latest smartphones, um, I think one shot will be enough because vines are not as tall as the trees. Um, so I don't anticipate scanning at this time. If you really want to take a whole row, certainly we need to scan, but the technique that we are proposing is not the exclusive or the comprehensive scanning of everything that's there. It's the sampling based estimation. That means we'll take one image of a given vine and go to the next sampling location and take another sample. And I don't anticipate mosaicing multiple images together to capture the vines. I think we can capture by a single shot.
Okay. What's the best resolution of image for the camera for getting the minimum as well as the maximum accuracy?
We have not done as much of the resolution based um, accuracy assessment in terms of the, let's say, what is the optimal resolution that we would like. Right now, we're using one or two cell phones with good resolution, 4K, in terms of pixels, and we're taking images from about 3 feet. I haven't converted that into the pixel size physically, but there are at least a couple of hundred pixels per clusters, maybe more, and that is giving us reasonable accuracy at this time. As we also discussed earlier, this goes down to the distance from the canopies and the number of pixels that are there in that given imaging system. When we are at this stage of releasing this application, we'll provide certain protocol for these kinds of sensors. This should be the optimal distance. But at the same time, if we were able to add the depth information to it, then that becomes much more simpler for users and also to define that protocol. Long story short, I think we don't have the range of resolutions evaluated yet, but we have one or two kinds that are working pretty well for us.
Okay. I think you kind of answered the day versus nighttime. How broad is the intended estimation? Per vine, per block, per vineyard?
The current accomplishment or the current version that I presented today can be used for estimating per vine, these many clusters and these many berries per vine. And then the next phase that I discussed was to go from there to the block level. In that case, at least from the theoretical conceptual point of view, it does not depend on the size of the field. It could be any size as long as we have sufficient samples collected for that field. Now, how users want to use it, I think this depends on their own management styles and philosophies. But once we go from a vine to a given area. It could be any size of that area.
Okay. And then are you working with a viticulturist to determine a trellis that might work better to expose at least 80% of the fruit to get a closer yield estimation? I could see this working well with table grape vineyards since the fruit is fully exposed.
Very good question. We have discussed about visibility or the exposure quite a bit during our proposal evaluation phases as well. Better the visibility exposure, more certain will be, or more reliable the results would be. It's more reliability than accuracy, actually. If I say we are going to get 6 tons an acre and we are 95% certain, it's much more useful information than if I say the same information, 6 tons an acre, but I'm only 50% certain about it. So yeah, whatever way we look at it, but this information that we will get out of it would be much more valuable if we have more, if these clusters are more visible. Now, how do we achieve there? We have not really started talking about altering the trellis system at this time. We have discussed about potential ways to perhaps even using some wind or other ways to kind of remove the leaves a little, or de-leafing. All possibilities have been discussed. There might be more other possibilities there, but we have not really started looking at that aspect yet. We'll see what we can do with the current systems in some of these commercial as well as research vineyards that we have access to. And then we'll come back and report this is what we got. And that time, perhaps we'll discuss more.
And then the last one is, now that phones are LiDAR capable, is that something that might be utilized in the future?
That's exactly what I meant by 3D information. Very good question. So we'll be using that, and it will simplify the overall job a lot, both for the programmers, developers, and the users. Are we? We're going to look at it from now, at this time, in this next phase. We have not explored that capability in the past, so I cannot be certain when that will be available in the app, but I'm pretty sure it will be included by the end of this phase of the project.
So that's it for the questions. So if I heard you, we're about 2 years out before we would have something growers could initially start to use in a beta test kind of format.
I think within the next 2 years, I feel like at this time my expectation is that we'll have a beta version somewhere between now and the end of the project, so that we have some time to see how users are using it and what they're getting out of it before the project ends, so that we can make some improvement, and at the end of the project we release a bit more stable and something that has been tested to some extent by the growers. So slight correction there. There will be somewhere between now and the end of this project, at least let's say 6 months before the end of the project, so that we have, or at least one season, let's say, before the end of the project, so that there is something. That is what I'll be working hard for.
Great. Well, our time is over just a few minutes, so we want to be respectful of everybody's time. So thank you very much. And as I mentioned, we will have a recording on our website, and also it will be sent to you in an email here, follow-up email. If you've got any questions, I do know I can share from personal knowledge here that we have a team of industry people that are working closely with Dr. Karkee to keep him on track and keep things realistic for the growers. So we look forward to great things.
Well, thank you, everybody. And thank you especially, Melissa, for this opportunity to share what we're doing. And anybody in the audience, if you have more ideas, more suggestions, and you feel like there are things that we could improve on, I'd always be happy and open to those ideas. And any way you'd like to communicate, call, email, even social media that you can find me in. I would be happy to hear from you.
Okay, with that, I will close things out. So thanks again.
Thank you very much. Bye-bye.
Bye-bye.